It's like I don't care about nothing, man. Yeah. Oh,
What's going on, guys? Coach Car here, ready to bring you another video. Now this one is also on partitions, so it's just more practice, so I hope you enjoy. Alright, so first problem on this one is number 6 on page 14. It says JK in the coordinate plane has endpoints with coordinates of -4, 11 and 8, -1. Graph and calculate the two possible locations for point M. So M divides JK into two parts with lengths in a ratio of 1 to 3. So that means that we're going to have one where we do it where this is our x1, y1, and this is our x2, y2, and then the opposite where this is our x1, y1, and this one's our x2, y2. So let's go ahead and do it.
Wow.
So with this one, now I have all the work shown. So first thing we need to know is what our k is. K was 1/4 because it gave us this ratio. So 1 goes on top because that's the first one there, and then you add them together, and that's what's in the denominator. So first one I did was I made it so this is my x1, y1, this is my x2, y2. When I go through and do the math, I then get -1 for x, 8 for y. So -1, 8. So just make sure you do parentheses first, multiply k with what was ever in the parentheses, and then we do 12/4 got us 3, -4 plus 3. So same method on both sides and how we solve it. So they told us that was our two possible locations. So when I plotted them, the J and the K, no, I'm not just kidding. Get it? Get it? That's a good joke.
How do I reach these kids?
Now, that one was at -1, 8, which does go on this line. So that one looks like it should be correct. Now, on the next one, I switched it up, made this my x1, y1, and this my x2, y2, because it wanted us to do the two possible locations for M. So when I did this, I had this, did my parentheses first. It came out to be -12 for the x value, multiplied it. Now I have 8 minus 12/4, which gives me 8 minus 3, which is 5. On this one, in my parentheses, I had 11 plus 1. The reason I have a plus is because of the negative sign. So it was minus a negative, which changes the sign to a plus. So now I have -1 plus 1/4 times 12, which gives me -1 plus 12/4. 12/4 is 3. So -1 plus 3 is 2. So this one was at 5, 2. So again, so this would be my x value, this would be my y value. And at 5, 2, that is also on the line. So it looks like I did it correct.
That is correct.
So now it's time to do part B. It's saying suppose J, P, and K are collinear on the line segment JK, and JP to JK is 1/3, where the coordinates of P. So main thing to remember is when you have 1/3, instead of it saying a ratio of something, we actually use that as our K. So before I do some movie magic, I'm just going to go ahead and say K equals 1/3. So with this one, J was at -4, 11. K is at 8, -1. So remember that, again, 1/3 tells us that's what our K is actually going to be, because it doesn't say a ratio of. Now, with this, we have, when I set it up, J is my x1, y1, k is my x2, y2. So I have negative 4 plus 1 over 3, and in parentheses 8 plus 4. So I do the parentheses first, and I get 12. So now I have negative 4 plus 1 over 3 times 12. I put it over 1 so that my numerators can go together, denominators go together. So now I have negative 4 plus 12 over 3. And 12 over 3 is 4, so negative 4 plus 4 gives me 0. Next one here, I have 11 plus 1 over 3, and in parentheses negative 1 minus 11. I have 11 plus 1 over 3, and in parentheses negative 12. I put it over 1, so it's easier to multiply them. Numerators together, denominators together. So 11 minus 12 over 3. That would make it negative 4. So 11 minus 4 is 7. So my point would be at 0, 7. So now we are looking at number 7. 7 is a little bit different from the problems that we've been doing because in this one it's saying points C, D, and E are collinear on CE, and CD to DE is 3 over 5. C is located at 1, 8, D is located at 4, 5, and E is located at X, Y. What are the values of X and Y? So what makes this one different is the fact that we have to find an endpoint instead of the partition. So we are actually going to be working backwards, and you will see that right now.
Wow.
All right, so let's walk you through this problem. Now we have it so that C is our x1, y1. I accidentally put a 2 there. That's supposed
What an idiot.
to be a 1. And D is our partition point. So that's what everything's going to end up equaling. So for my x values, it equals 4. For my y values, it equals 5. We are trying to find the other endpoint. So for the x values, I have 1 plus 3 over 5 times x minus 1 equals 4. So the x is going to be the x value for our e. So 1 plus, what I did was I distributed it into it. So now I have 3x over 5 minus 3 over 5 equals 4. I just rewrote it so what I can combine is next to each other. So 1 over 1 minus 3 over 5. Reason that I put it over 1 is so that now I can change my denominator, because when you're adding or subtracting, they have to have the same denominator. So 5 minus 3 gave me 2. Denominator stays the same as 5. Plus, now I bring down the rest, 3x over 5 equals 4. Now I subtract the 2 over 5 to each side so that it cancels out over here. And when you subtract fractions, the denominator actually does have to be the same. So the 4 changed to 20 over 5. And so 20 minus 2 is 18. The denominator will stay the same as 5. So I have 3x over 5 equals 18 over 5. I'm trying to get x by itself, so the way that we actually make a fraction like this go away is by multiplying each side by the opposite of it. So I flipped them in essence. So now when I do that over here, 18 times 5 gives me 90. 5 times 3 is 15. And when I do 90 divided by 15, I get 6. Now, next over her, we have the 8 plus 3 over 5, and in parentheses y minus 8 equals 5. So now we do our distribution first. 8 plus 3y over 5 minus 24 over 5 equals 5. So I went ahead and just put what I'm going to combine next to each other. So 8 over 1 minus 24 over 5. Now again, when you're adding or subtracting fractions, you have to have the same denominator. So this turned into 40 over 5. So 40 minus 24 is 16. The denominator stays the same as 5. And then I brought everything else down. 3y over 5 equals 5. So now I'm subtracting this fraction to both sides. So I subtracted 16 over 5. Now in order to subtract it on this side, it had to have the same denominator. So I multiply the bottom and the top by 5. So I have 25 minus 16 gives me 9. And then the denominator stayed the same. So you have 3y over 5 equals 9 over 5. And now the way to get rid of this 3 over 5 is by multiplying it by what it would be flipped. So if it were flipped, 5 over 3, which cancels it out on this side. So 9 times 5 is 45. 5 times 3 is 15. So 45 divided by 15 gives me 3. So the end point will be 6, 3. So my x value would be 6, my y value would be 3. So one more problem on here. The one that we're looking at is number 9 on page 15. Draw what the segment would look like if it's partitioned in a ratio of 1 to 1. What is the name for this point? So if it were partitioned 1 to 1, then what we're saying is both partitions should be the same length. If it's the same length, this point in the middle would be called a midpoint. This might be a foreshadowing for the next video. So that's the end of another video. Make sure for practice to do page 15, number 8. I forgot to change my board, so yeah, that's the end of the video. Have a great rest of the day.